A really quiet revolution is brewing in the world of AI. I'm talking about the most powerful models, the ones that used to be locked away in giant corporate data centers. They're now starting to show up on our own personal computers. So this is the story of how that's even possible, and more importantly, why it's such a game-changing shift in who really holds the power. So, for the longest time, right, the best AI models, what we call the frontier models, have pretty much been the exclusive playground for a handful of tech giants. I mean, they're incredibly powerful, no doubt about it, but they've also been almost completely inaccessible to the rest of us, hidden behind super expensive APIs and these really restrictive walled gardens that control everything you can do. And this really shows you the two completely different ways of thinking about AI. On one hand, you've got cloud AI. Sure, it's powerful, but there's always a catch, right? You're constantly paying for access, you're sending your data off to some third party, and you're basically at the mercy of their rules. But now, local AI is starting to pop up. And this is different. It's yours to control. It's private right from the get-go. And hey, once you've got the hardware, it costs nothing to run. This isn't just some small technical detail. It is a fundamental shift in the whole power dynamic. So what's actually making this shift happen? Well, it's this new wave of AI models that are not just powerful, but also surprisingly efficient. And honestly, leading the charge is this one model called Miniax M2.5. It's the one that's really starting to break free from the old school limits of the cloud. And please, don't make the mistake of thinking local means less powerful. Just look at these benchmarks. M2.5 isn't just kind of competing with the big names like Gemini and Claude Opus. No, it's going toe-to-toe with them on some of the toughest reasoning and coding tasks that exist. We're not talking about a compromise here. This is a genuine breakthrough in both power and, just making it available to everyone. So what can it actually do? Well, its skills are laser-focused on real-world stuff that's actually valuable. We're talking about state-of-the-art coding that doesn't just fix bugs, it can design entire software systems from scratch. It can also act like a true agent, using tools to do expert-level research. And it can even whip up professional-grade documents for your office work. This is an AI that is absolutely ready to be put to work right now. And get this, even if you use it the old-fashioned way through an API, M2.5 is ridiculously cheap. Its creators are aiming for what they call intelligence too cheap to meter. I mean, just 30 cents an hour? That's an absolute bargain. But what if you could just get rid of that cost completely? What if it was zero? Well, that's the promise of running it on your own machine. Okay, so here's the big question. How on earth do you take a model this huge and shrink it down so it can run on a single computer? It honestly sounds like a magic trick, but I promise you it's just a really, really brilliant piece of engineering. First off, let's just take a second to really appreciate the scale of this challenge. The original, full-precision version of this Miniax M2.5 model is a staggering 457 gigabytes. Let that sink in for a moment. That's not just big, it's colossal. It's way beyond what even the most high-end gaming PC could handle. But then, through this process called quantization, bam, that massive model gets shrunk down to just 101 gigabytes. Okay, it's still a pretty big file, for sure. But now we're in the realm of possibility for a single powerful machine. I mean, this bar chart right here tells the whole story. We're looking at a mind-blowing 62% reduction in the model's file size. And this all happens through quantization, which is just a super clever way of reducing the precision of the numbers inside the AI without really hurting its performance. Think of it like compressing a huge, high-resolution photo. You might lose a tiny, tiny bit of detail that you'd never notice, but the overall picture stays incredibly sharp. The real key that unlocks all of this is a file format called GGUF. The easiest way to think about it is like a special zip file, but made just for AI models. It doesn't just shrink the model down to a size you can actually handle, it also tunes it up to run super efficiently on your computer's hardware, instead of needing some giant server farm in a data center. Now the real magic, the secret sauce, comes from a company called Unsloth and their technique which they call Dynamic Quantization. It's like a super smart compression tool for AI. It goes in and reduces the precision for most of the model, but, and this is the clever part, it's smart enough to find the absolutely critical layers and keep those at high precision. And the result? A way, way smaller file with almost zero noticeable drop in quality. It's brilliant. Okay, so that's the theory. Enough talk, right? Let's see how this all actually comes together in practice. We're going to look at a real-world demo of this powerful AI running on just one machine. And you know what's really amazing? Just how straightforward this whole process is becoming. You just use this open source tool called Llama.cpp, you download the shrunken model, you give it a prompt, and you get a result. It's that simple. It's really a testament to the power of the open source community, making something this complicated so accessible to everyone. So, to really put this thing through its paces, they gave the model a seriously challenging task: create a complete, self-contained, interactive web page for a made-up AI coding assistant. And we're not just talking about spitting out a few lines of code here. This means handling the logic, the layout, the styling, the functionality, the whole shebang, all in one go. And the performance? Wow. On just a single GPU, it was cranking out code at nearly 25 tokens per second. Now, to put that into perspective for you, that is a totally usable speed for actual development work. This isn't just some tech demo or a proof of concept. It's a practical, efficient tool you could use today. Honestly, the reaction from the person who ran the test really says it all. He just said, "Look how good that is. No malformation. The whole page is quite good. There are no mistakes at all." The final result wasn't just functional, it was flawless. It just worked perfectly. So, what does this all add up to? What's the big picture? It means the future of AI is local. We are literally watching the democratization of artificial intelligence happen in real time, as the power to create and innovate shifts from just a few tech giants into the hands of, well, anyone with a powerful enough computer. And why is this such a big deal? Let's break it down. First, ultimate privacy. Your sensitive data, for healthcare, finance, whatever, it never leaves your device. Second, zero API costs. You're free to experiment and build as much as you want without some meter running in the background. Third, you get total control to customize models for exactly what you need. And of course, it works completely offline, which opens up a whole world of possibilities for apps in places with no internet. And this isn't just some niche experiment for hobbyists. As Merlin AI, the creator of the original video, put it, quote, "I believe this is what the future of AI deployment looks like going forward." And you can see why. The benefits are just too compelling to ignore. And it is so important to remember that this entire revolution is being powered by the incredible work of the open source community. You've got projects like Llama.cpp that provide the engine, and then innovators like Unsloth who are creating the fuel. It's this massive collaborative effort that's pushing the whole field forward, and it's just an amazing testament to the power of sharing knowledge. So, all this leaves us with a really exhilarating question, doesn't it? This technology, it's not some distant dream anymore. It's here, it's accessible, and it is ready to be unleashed. So when every developer, every creator, every single curious mind out there has access to this kind of frontier-level AI right on their own machine, what are we going to build next? The possibilities really are limited only by our imagination.